good afternoon, good morning, wherever you are. So we are here for the office hours episode. We are on the 16th already, so quite a few on our back. For this one, I have with me Satya, who is also from our product team, and will be joining the stage here for the Netdata FAQs demystified. So hopefully we get some interesting questions and answers for you to get a better grasp of what Netdata is able to do, what is around Netdata, and yeah, with links to our Learn documentation. So if you want to read more details. So first of all, thanks Satya for accepting the invitation and joining me on stage.
Thanks, Hugo, for having me here, and welcome all of you. Hopefully, this will help you demystify some of the questions you might have as well. We've seen this, very common with most of our user base. So, hopefully, we can resolve some of those queries.
Cool. So as I've seen here, there's also questions coming up. If you have questions to share that you would like us to address, please share it on the chat. If they are not on the deck, we'll try to address them. And in regards to this one, that we can already start with this one from the chat. So can we integrate Netdata with OpenTelemetry? Yes, we follow the standards around OpenTelemetry and Open Metrics, and we are always trying to improve our product towards that direction. So you can integrate with Prometheus metrics and this kind of standards. So it's something we are pushing for that data to be compatible with. So let me start with sharing the deck, the presentation. So sharing my screen in a second. Sorry, the wrong one. So this one. So as I mentioned, today's episode is around the FAQs, and we want to demystify those. We started with introduction, so the spotlight is what we said, and we'll end with a slot for open questions. So you can start popping them on the chat if you have, and in the end we'll go through them. And if you have any other question at the end, we can go through that. Yeah. So we have a couple of questions that we selected based on customer calls, customer support requests that we get, and we gather this as a kind of an index for what we'll be covering on the presentation. Each one is navigated to the slides where we cover it, and also a link to the Learn page where you get more details and more facts on those. Yeah. So I will not go through all of these here because we'll see them each one by one. So we probably spare you the effort to go there.
Yeah, and I think for a change, let me put Hugo on the spot. I will be the one posting questions. Uh, I'm sure Hugo will be answering most of them, if not all of them, and I will jump in wherever I think I want to add, if that doesn't disturb Hugo. Hugo, so are you ready?
Yes, let's do it.
Okay, so one of the most common questions that we receive in most of our customer calls, or also with users whom we interact to kind of look at how Netdata is deployed in their infrastructure. The first thing that becomes evident is what deployment options are available. So Hugo, if you can just quickly go through and explain to our users what deployment options are available, and to an extent which one is suitable for what kind of scenarios. All
For
yours.
sure, for sure. Thanks, Satya, for the intro and the question. So I think first of all we should start with the three main components that we have on Netdata, and these make Netdata a very modular monitoring solution, which allows us then to create what we call the distributed monitoring solution that Netdata is capable to provide to you. And for here, we start with the Netdata agent. So this is the component or the application that will run on your physical or virtual nodes on your infrastructure, and it can monitor the applications that are running there or the containers that are running there. So it's the component responsible for collecting, storing, and sending data, the metrics data to the visualization that you're going to have, either the local dashboard of the agent or our cloud if you use the cloud. These agents are open source, so it's the open source component of Netdata that you have here. And as I mentioned, with the local dashboard that it brings, it's already a full-fledged monitoring solution by itself, just the Net agent by itself. Um, the next one is the Netdata parent. So this is an implementation over the Netdata agent. This parent is like an observability centralization point that you will have on your infrastructure, where you can get a parent agent being collecting data from multiple children. So the children agents will stream the data to this parent. So the key benefits that you get from setting up a Netdata parent is going to be offloading the load you might have on your production systems. So you don't want your servers that are running your applications and supporting your business to be the ones providing the metrics and the data to the dashboard that you're going to see. So with streaming the data to a parent agent, that is going to be your monitoring component, let's say, you offload this load from your servers. And another important point is to create some high availability of your data. So if you have the data streamed from an agent to a parent, you're basically duplicating the data that you're collecting on that server. And even then you can create clusters. We'll see that further ahead, but you can create clusters of parent agents to create more redundancy and more high availability on this. Um, Another important point is if you want to increase data retention as well. So if you have limited resources on the edge, child agents that you're running, you can stream the data to a parent agent that you give more resources. It is going to be a more robust kind of a machine and server. And with that, you can increase your data retention because your leaf or edge agents will have lower capacity and lower resources that you provide to them, but knowing that your parent agent is going to keep your data for longer time. And lastly, but also an important point, you can have isolation of your nodes. So if your nodes that are running the net agents on the edge again cannot connect to the internet, cannot connect to the outside world, you just need to create a bridge to the Netdata parent. So the Netdata parent will get the data from those nodes, and then it's going to be the Netdata parent that will provide the data outside of your infra if you need to expose it somewhere there. So we recommend the setup of multiple Netdata agent parents. If you have a big infrastructure, you might need more than one. So it depends on the size that you have. And if you integrate them with our cloud, you're going to create a seamless monitoring solution with this kind of setup.
So just
And
to kind of summarize what you said, Hugo, in the traditional monitoring terminology, the Netdata parent kind of behaves like a monitoring server, right?
yeah.
Which has a little bit more power. It is bulkier, but can then cater to hundreds of devices connecting to it. You take care of data retention. You also take care of centralizing your alerts. You take care of a lot of centralization around machine learning. So can we actually term it as the monitoring server coming from a data perspective? Although that's an age-old terminology.
Mm-hmm. It relates to that. On our Learn, I think we call them the observability centralization points, but that's the same thing. So we are creating these central points for your observability of your infrastructure. But it's the same metaphor, let's say, that you're using there. And lastly, the last component that we mentioned here is our Netdata Cloud, which is our SaaS offering. And this allows you to combine all your infrastructure. So all your Netdata agents and parents, and you can create like an uniform, and as I mentioned, distributed monitoring solution, scalable and fully connected and fully seamless to you. So you connect that to cloud, to our Netdata Cloud, and you have access to all your infrastructure independent of the multiple zones or multiple hybrid cloud environments or multiple centers you have with multiple data parents for each of them. So cloud unifies all of that, and for you is going to be totally transparent, this kind of view. And I think there's an important call out here that in either of these cases or either of these components that we are speaking about, the data that is being collected for your metrics is stored always on your premises. Even when you use our Netdata Cloud, we don't stream the data we don't collect the data on our cloud centrally. When you're viewing a cloud dashboard, what will happen is that to fulfill the request or the data that you need to see on the dashboard, cloud will trigger multiple requests to the respective Netdata parents or child agents if you don't have a parent for that, so the agent himself, to get the data that you need to visualize on the dashboard. So we'll never store your metrics data on our database in cloud. So we just store some metadata to know how to stream the request or to send the request, let's say, to the correct agent to get the data you need on the dashboard.
So it is a completely decentralized distributed architecture where the cloud kind of acts just as a visualization entity, and the agents, Netdata agents, and the parents are where all of the computation and the collection happens.
Exactly. Exactly. So moving on to some of the deployment scenarios. So this was more introducing the components, and now we start creating some kind of examples with these components. So in this case, we are looking to standalone deployments where each agent will act as a standalone monitoring system by default, and then you can combine this with using cloud or not using cloud. So in the first case, we have each one of the agents providing a specific URL for each of the agents that we spoke about. So we have multiple independent dashboards, and if you want to monitor like the standalone Netdata one, you need to go to the URL specifically for that agent. So you manually choose which agent or which dashboard you want to access and to visualize. So it's an access for each specific agent. And probably to add some more details on that, um, even when we speak about logs and viewing logs, you need to access again each one of them. You don't have central alerts, so each of these agents is going to be responsible to send the alerts for each of their health checks that they are running. And again, but the data is still, of course, in each of these agents is on-prem exclusively. If we map to the second case, which is where we are using Netdata Cloud, so you connect each one of the agents to our cloud, our SaaS service. In this case, when you want to monitor the servers, you can access cloud, so only cloud, and you can see the full view of all the three agents in a kind of a composite view of everything. But then you can also access individually each one of the agents to see the specific metrics for each one of them. So this is what we call an unified dashboard for all the nodes that you have. And here, besides the metrics that are going to be visualized centrally, the logs can also be accessed centrally from cloud. The alerts you will be dispatched by cloud, so you can disable the alerts triggering notifications from the agents. So cloud can do this centralized dispatch of alerts by itself. You don't need to have the agents sending it. And again, as we said, even though we are using cloud, the data is on-prem on each one of the agents. Yeah.
And I think if I can
So
just add one thing which you
sure.
brought upon a little bit, Hugo, yourself, is the access of each of these dashboards. Without connecting to the cloud, you are restricted to being on the same network. So to access those dashboards, you will need to be on those networks, provided it is behind a VPN or on some private network. But with the Netdata Cloud connectivity, you can access your dashboards from anywhere securely. Right? I think that's one of the key differentiations between these two, apart from the aggregated composite dashboards.
Exactly. You just authenticate yourself with Netdata Cloud with your credentials, and then you have access to the agents wherever they are. You don't need to be on the same VPN or firewall or through a firewall to access them. Yeah, very good point. So moving on to a different case. This one is where we have a deployment with centralization points. So the observability centralization points that we spoke just a moment ago. So in this case, we have two different Netdata parent agents, each one acting as a centralization observability point, one for some AWS cloud deployment, and another one for some on-prem data center that you have. In this case, you connect to cloud the two parents, and through the parents, cloud can access the data to all the children that are below the parents. So again, just going to some details that are on the slides. Each of the child agent is called the sender of the data. It will send the data to the parent, and the parent is the receiver. So the parent will have replication, let's say, that of the data that is on each of the child nodes. And when it gets a query from cloud, it will see that it has the data for that child himself and get the data for cloud. So the queries will not be triggered on the child nodes if the parents can satisfy the request. That's where the part we said it allows you to offload the load on the edge servers if you need to protect them, let's say, from being part of querying in terms of the observability work that your team is doing. So yeah, this is for metrics and for logs, as it says here. So it tries to satisfy the queries always from the parents. And this is a simple example with just 2 observability points. But as we said, this is totally scalable. You can have as many parents as you need and as you want, depending if it's restrictions per different cloud environments. You can have as many as you want, and even inside each of these isolated environments, you can have multiple. So it really depends on how you prefer to do your setup. In this case, the alerts, as Satya said in the previous slide, the parents can also have the responsibility to act as the health engine, let's say, or health check for the child nodes. You can disable the health engine on the child nodes. We'll see it in another slide about making them more efficient in terms of running the Netdata agent. So the parent can be the responsible to act as its own health engine and also as the health engine for its children. And the same thing for the machine learning capabilities. You can have the parents being responsible to have the training models for the child nodes. In this way, you again avoid more load on the edge nodes. In terms of alerts dispatching, again, it's from cloud. You can disable the alerts from the parents. It's not mandatory, but if you don't want to have duplicate alerts, it's kind of the advised. And another case, if you see from the cloud perspective, all the data is on-prem still. It's on your parents, it's on your child agents. Cloud doesn't have this data centrally. Yeah.
And I think this kind of becomes crucial in case of outages, right? So if assuming one of the child agents goes down and you want to monitor what is wrong with that agent, if it was not available and directly connected to cloud, there's no way for you to get the data. But given that the streaming is enabled, you will always have data until the outage happened for that agent for you to be able to troubleshoot. So I think in production deployments, who will correct me if I'm wrong, having parent agents for high availability and redundancy kind of becomes very crucial, right?
Yeah, you're touching exactly on the next slide, the next point. So as Satya was saying, so if you want to have a high availability monitoring deployment, you should have parents streaming the data even between themselves. So we call it the active cluster between parents. So the configuration is all your child nodes will be set up to stream to the parent A and to the parent B, but at a given point in time, they will only be streaming to one of them, the first one that they can connect to. If the parent A, for some reason, goes down, they will immediately connect to parent B. So they start streaming to the other available parent. But there's no loss of data because the 2 parents are streaming the data of the children between themselves. So if one parent goes down, as soon as it comes back again, the other parent will stream the data back, the missing data, to the parent that went down. So in this case, if a parent goes down and you're doing this through cloud, it will be totally transparent to you because cloud knows which of the nodes is up and it will direct the queries to that node that can satisfy the queries that you're looking at. So parent going down, it's totally transparent and totally irrelevant, let's say, in a case for getting access to the data. So this is, as we were saying, the ideal setup for a production environment where you need to make sure you have access to your monitoring data at any point in time.
Yeah, Hugo, maybe I'll ask one question on behalf of the users, which I've heard from some of our users and customers. Can we have, in terms of replication between parents, a parent cluster, or is it always just active, as in just 2 parents?
You mean having more than 2 parents on a cluster?
Within a cluster. So for the active redundancy between parents, so here we have, if one of the parents goes down, it works. Uh, this is just a question that came up. I know there is a capability to do that. Do you think that is necessary in some cases to have multiple parent redundancy as an active or n+1 active redundancy kind of a scenario?
The problem is I'm not sure I'm getting the question right. So what we are speaking is about having 2 parents on a cluster. We consider those 2 parents as part of a cluster,
Yeah,
that they're responsible for a group of child nodes. And
correct.
these parents because they are on the same cluster, will be streaming the data to themselves. So that's what we call creating the active cluster. Is this the
Correct.
question that you raised, or?
Yeah. So, for example, there is a parent C,
Okay.
and we want an active cluster, or like they say, n plus one
Okay.
active cluster. This is some questions that has come up, and maybe some of our users are interested. Uh, is that something that is even necessary or recommended? Is that even possible? Because I have not seen any of the users using it. I know in principle it is possible. So if you have any pointers around that, if not, we can actually move to the next point. It's just something that came up
Yeah, yeah.
from some
I think
customer
I
discussions.
think it is possible. I think I've never seen that setup as well so far. But the way these streaming capabilities and the streaming between parents was created and with the children is to be totally flexible. So you can almost do whatever setup you want, and you can even create grandparents, let's say, on top of the parents. So you can really create a hierarchy tree of multiple parents and children and grandparent nodes. So this is as we try to create the
Yeah.
flexibility for any kind of setup, basically.
Yeah, I think that makes sense, right? Multi-level parents probably makes more sense than having more redundancy at one level. Yeah, okay, that
Yeah,
makes
yeah.
sense. Uh,
Good question, Satya.
yeah, I'm sorry, I had to kind of stump you a little bit, but I know these are some of the questions that have come in from our users. I just wanted to see if you have a different take on it, and you did. Thanks for that. Um, okay, I think we can move to the next question that has been very often asked also on our Discord channels by a number of users. So, how do we optimize our Netdata agent deployment in terms of resources that need to be allocated to them?
Mhm. So basically, Netdata, when it runs, it tries to adjust this resource consumption based to the workload that it's available and the capacity that is available for it. But I think before we go into how to optimize it, we should look to what each of the different capabilities or features, let's say, that the agent has and what impacts on resources they have. So metric collection, it has impacts on almost everything. So CPU, RAM, disk IO, disk space, retention. So it's kind of understandable why this is like that. Um, Sample collection frequency, so how frequent you collect the data, has mainly impacts on the same things except RAM. So we are just kind of using the CPU cycles to collect the data and then, of course, store it on disk and make it kind of a stay there, let's say. Then we have the database mode and the tiers. So you can set up Netdata agents to run just on RAM. You can have multiple, it can run on DB engine, which is our time series database that we created specifically for Netdata. And you can set up different tiers of retention of data and different resolutions of retention. And we'll see that more ahead. So this kind of feature impacts on the RAM, disk IO, disk space, and retention. And then going to machine learning, this is mostly around CPU and RAM that this feature is going to impact. And the streaming that we have been speaking up until now impacts CPU, RAM, and bandwidth because of course, the connection to the receiver agent that will receive the data. So now going into how can we kind of optimize this? So um, this most of the cases, if you use a Netdata parent, as we have been saying, you can minimize the resource consumption on the edge nodes. So you can, again, as we said, disable the health engine on child nodes, can disable the machine learning on child nodes, and delegate all of that to the parent. And even because of the queries that we get from the dashboards, since the parents are the ones that are going to kind of satisfy those queries, you again minimize the impact on the child node. So that's kind of the first recommendation that we give. But in case this is not an option for you or you don't want to use it, there's other points you can look at and other things you can do on a Netdata agent by itself. So in terms of metrics collected, as we saw, it impacts most of the resources. And the first thing you need to look at is look what the data collections or plugins you should disable. If you don't need them to be collecting, if you don't need them to do your troubleshooting and monitoring, you should look at disabling some of this data if you don't need it. So that's one of the first things. Another one is the sample collection frequency. So with Netdata, we try to collect metrics to the lowest frequency possible, like per second in the most metrics that we can get. There's of course some exceptions where we can only collect by 5 seconds resolution, but most of them it's per second. So if you reduce this frequency, the collection frequency, instead of being per 1 second to be 2 seconds or 3 seconds or whatever is acceptable to you, you will reduce the CPU utilization by the same proportion, let's say. So if instead 1 second you go 2 seconds, you halve the CPU utilization just by that. And the next one around the database mode and tiers. So by default, we store the metrics in 3 tiers. So the number of tiers, since we are kind of collecting and storing the metrics in each of the tiers every moment, this uses a lot of memory. If you reduce the number of tiers, the memory consumption will reduce, but then this impacts your data retention. So it's kind of a balance you need to make between having more lower impacts on memory, but potentially lower retention. And the next one, as I was saying, by default, Netdata trains the multiple machine learning models for all the metrics that we collect. And if this is not needed on our specific agent, because as we said, you have it on a parent, or you don't need it to be on that agent, you can look at disabling it as an option.
Great. That was quite a detailed explanation, Ugo. But in principle, this can all be done within a single configuration file, I presume. So it should not be as complex, although the description looks complex. So I think for
Exactly.
anyone who's been looking for this option, you should definitely go try it out. And as part of this slide deck, which has been shared on the chat, you have links to specifically these documentations on our Learn, which will assist you with how this can be done, right, at a configuration level.
Yep.
Uh,
Yep.
but yeah, thanks, Hugo, for that very detailed explanation. Now, I think we come to the next question, which you already kind of touched upon a little bit. How can I increase the data retention of my metrics? What does Netdata come by default? How can I increase it? And how long can I actually have data retention for? If you can cover some of those topics.
Sure. So as I mentioned on the previous slide, by default, the Netdata is using the DB engine, which is our time series database that was built for this purpose. And it comes with a setup of 3 tiers. We'll see the details of each tier in the next slide, but this is a sample of a configuration file of that. To increase or decrease the metric retention, you need to configure the number of storage that each tier will have and how much allocation you want to give to each of the tiers. So you control the resource that you give to the Netdata agent in terms of storage. So as we mentioned, we don't store it centrally on cloud. So if you need to give more storage to your agent, you need to give more storage capacity to your agent. And then you control on each of the tiers how much storage allocation you have for each of the tiers. But take in consideration that different allocation of memory can be different for different servers. So the retention period will be impacted by the number of metrics that you collect per second. So if one server collects 1,000 metrics, it will have certain number of storage. If another server collects 2,000 metrics per second, it will have half of the storage capacity. So the number of metrics collected is an important factor to tell how that storage will change. And moving to the next slide, we can see an example that is here. So we have a kind of a rule of thumb, let's say, that for the first tier that we store the data per second, we need 1 byte per data point on disk for that. For the next tier is like 6 bytes per data point, and on the next tiers is 16 bytes per data point. Taking an example of 1,000 metrics collected per second, for the first tier, you have a retention of 3 days. So you can go to the level of per second resolution during the last 3 days. If you above that, you go to the tier 1, which is like per minute resolution, and that tier will store for 15 days. I mean, sorry, I need to show the default value. So this is considering the memory location that's missing on the table. I'll make an addendum to update the table. So for this is like 256 megabytes on tier 0, 128 megabytes on tier 1, and 64 megabytes on tier 2. This is an important detail. I'll make sure to add it on the table. So this is considering this memory allocation that I was speaking on the previous slide. And then if you go to the next tier per hour, you can go to almost half a year of retention. So this is considering those memory allocations for a sample of 1,000 metrics collected per second. So if you need to increase these retentions, taking this example, you will need to review the allocated memory to each of the tiers that we just spoke in the previous slide.
Thanks, Hugo. Again, a very detailed explanation, but I think the users will need to try it out themselves, especially on Netdata parents, where you need to calculate how much storage is needed across multiple child agents. But it's something that we highly recommend to do.
Yeah,
And again,
and
it's quite simple to do as well, right? Yeah, go ahead,
yeah.
Hugo.
I was saying that actually our recommendation in most of the cases is to leave the parent agent running for some days, collecting the data that you get from all the child nodes, so you can get a picture of how many metrics the parent agent will get. So you give enough capacity of allocated memory for allocated storage to collect that, and then you can tweak and fine tune your location based on real data, on real facts. So you'll know parent agent A will get 10,000 of metrics or something like that. So you should get this running to be able to see the data and then decide how to best optimize your allocated memory storage. Sorry.
Yeah, absolutely. Okay, I think we're kind of running slightly behind time, but let's go to the next one. You've already touched upon what a Netdata parent is, what is a centralization point. But I think here, the one question that comes from our users is what is the benefit of having a centralization point? So maybe you
Yeah.
can cover some of those aspects.
Yeah, I think we can cover it pretty quickly. So decentralization points, as we said, it's to aggregate metrics, logs, and metadata from multiple channel nodes in your infrastructure. And the first point that you get benefit from is creating this high availability. So you get data redundancy from your child replicated to the parents. If you have active parents, you even replicate between them. So high availability is for sure one key factor or benefit you get from setting up Netdata parent agents. Another example that also Sati mentioned briefly is the ephemeral situation. So if your child node goes down, if you try to access the child agent dashboard, you cannot access because it is down. But if the parent agent is having the data for that child node, you have the history of all the data of that child node until the point it went down, until the point it stopped streaming to the parent. So you can really, in ephemeral scenarios like containers and pods going up and down in a Kubernetes environment or VMs that are ephemeral, you can centralize all of that to a parent agent and always have track of the data of these ephemeral nodes that go up and down as per need. So that's also an important benefit from parent agents. Another one that we briefly spoke about is the resource constraints. So if your child agent or the agents running on the edge have lack of resources or you need to protect your production systems, then putting the load on a parent agent helps you minimize the impacts on those. The next one is if you cannot use Netdata Cloud, you could have access to a multi-node dashboard through a Netdata parent. Of course, you only have access to the child nodes under that Netdata parent, so you don't have a full infrastructure view across parents. But for a parent accessing the local dashboard for that parent, you see the full child nodes that are under that parent. So if that's the other point that I think we also spoke about. So if the child or the edge nodes cannot connect to Netdata Cloud because they cannot connect to the outside world with firewall policy or something from your company, you can do a bridge through a Netdata parent. So the child streams to the parent. So it just needs to have the connection available and open for the parent. And then the parent is the one that will send a reply to the requests that come from Netdata Cloud. So even for these isolated scenarios, the Netdata parent also can help there.
I think this is the scenario where we talk about demilitarized zones, DMZs,
Yep.
where you have secure setup for all of your agents. They don't need to ever connect or communicate outside of the network, and only the Netdata parents will communicate with Netdata Cloud. It has been a very common scenario, especially in cloud deployments or even private data centers with security zones. It kind of makes a lot of sense.
Exactly. So then to complete this point on still the centralization point. So what are the factors you need to consider for deciding how to set up this? So the volume of the monitoring system, so the number of nodes you're going to monitor, will impact or define how many parents you need. And also the term of these DMZs that Satya was saying. So if you have different DMZs, at least per each of the DMZs, you'll need a net data parent. So the volume and the display of this infrastructure will decide how many parents you need. So the cost of data transfer is also an important point. So if you have your nodes in a given zone on your cloud deployment, you should have a parent in the same zone of those child nodes. So the streaming will be inside the same zone, and you don't do cross-zone transfers or cross-network transfers. So this part of taking into consideration the cost of data transfer between child and parent nodes is also an important factor. Um, the usability with Netdata Cloud. So if you have a lot of centralization points and you don't use cloud, you'll need to access each of the centralization points dashboard to see the child nodes. So if you need to minimize the number of network parents because of this, you should if you cannot use cloud. But of course, when you use cloud, this is totally transparent, and you can, independently of the restrictions that we spoke about above, you can focus on the security, cost control, and operational efficiency to dictate how many parents you want to set up. So this is, I would say, the ideal scenario, because Netdata Cloud will make everything transparent to you in the end.
Great. Thanks, Ugo. I think we'll take one more question and maybe briefly pause for checking to see if any of our users have any questions
Mm-hmm.
on the chat. The next question is, where should alerts and machine learning run? Or should they be at the edge? Where should they be essentially run? In production systems, home labs, wherever?
Yep.
If you can take that.
Sure. Well, again, it's kind of a point we already spoke a bit about. But again, if you can deploy these observability centralization points, the net data parents, the most efficient setup is to delegate these functionalities, let's say, to the parents. So you disable them on the child agents, on the net data children agents, and you have the parents running this on behalf of them. So you minimize the resource load on the child agents. Um, so in this example, the net data parent agents are more resource capable servers. So you already, when you do the planning for your servers, you're going to give more resources to this, and they take the load of the child tasks, of the child net data child tasks. Um, as we said, this reduces both the CPU consumption and RAM consumption based on the table that we saw a couple of slides back on the child node. If you also do the alert check on the parent, you avoid duplication of alert notifications. So you don't have the alerts running on the parent and on the children, and you'll be in a situation that you could get duplicate alerts. So that way you just have them coming from one single place. And this is a sample of how the network, sorry, how the notifications mechanism would work in a case of observability centralization point. So as we were seeing the other case of the two parent agents on different, one on AWS and the one on on-prem scenario. So as we are saying, the child node stream to the parents. The parents are the one running the else engine for the child. The child are not doing that. And then when there's an alert transition, some condition that says we need to trigger an alert, the parents are the ones that will send it to cloud to say there was an alert on a given child node or even on the parent itself. So it depends which was the node that triggered the alert. And then cloud will apply silencing rules, user settings, and decide, of course, based on the notification channels that you want to receive notifications from, it will trigger those notifications centrally from cloud. So parents optimize the checks on the alerts, and cloud will deal to dispatch the notifications to wherever they need to be dispatched. So this is an example of what would look like in terms of alert notifications in a scenario using parent nodes.
Yeah, thanks, Ugo. I think we'll give you also a little bit of break to get your breath. In the meanwhile, let's see if we have any questions. I know there's this question about the open telemetry compatibility, which we initially answered, but maybe just to bring that up here, We're not yet fully compatible with OpenTelemetry. It's on our roadmap for us to be completely compatible. Right now, for example, we are compatible with the UCUM units, which is what OpenTelemetry recognizes. There are quite a few complexities in terms of your metric names and the context names and how they need to be termed. So, given that the question is, are we able to import and export stuff directly from OpenTelemetry? Not 100% at this point in time. We know there are various OpenTelemetry kind of collectors which work with Netdata, but they're not seamless at this point in time. Some data may go miss, some data may be perfectly okay. But when we are completely ready, we will inform you. It's definitely on our roadmap. We want to be compatible with OpenTelemetry. Okay, any other questions? I don't see many more.
I think that's it. Yeah.
Yeah, okay. I think some of the questions coming up may raise some questions, or maybe Hugo, you've been so clear, there are no room for any further questions. Okay, so the next questions is around custom applications. It comes from all our customers. Okay, you have 800 plus integrations, across various things, but I have a custom application. How do I actually monitor this? It could be from users using their existing monitoring solution like, Zabbix, Nagios, whatever else. They could have created certain scripts and things like that. But how do we support, monitoring custom applications in Netdata?
Yep. Good question for sure. One that comes a lot. So we have like 4 generic means you can do to get these custom metrics. So if your application exposes metrics on a Prometheus endpoint, we have a generic Prometheus collector available, an integration available, which you can use to scrape your application metrics. So that's one of the first options. Another option is if your application exposes metrics through a statsd library, and there's a lot of libraries to different programming languages, you can use our generic statsd collector to also read or get the metrics from these statsd libraries. So that's also an available option. One a bit more probably generic and not so kind of common as the previous ones is if you have metrics in a format like CSV, JSON, XML, HTML, or some other available formats, you can use our generic structured data collector, which is the pandas, to collect the metrics from this type of files or this type of format files. So that's also an option you could use. And lastly, which is something you can also do that we already saw some users doing, is developing your own collector. And for that, we have some examples with Go and with Python that can use as a kind of a starting point, let's say. So you could also build your own collector. So at the moment, most of our most recent collectors are being done on Go. So probably that will be the recommended approach. But yeah, it's kind of up to you. So using any of these 4 options, you could stream, or you could send custom metrics to Netdata like this.
Thanks, Hugo. I've seen many of our customers using the Pandas collector recently because they had some kind of a script which generated an output. As long as the output is in a certain format, they found it extremely easy to generate metrics out of those. The initial assumption from their side was, okay, we need to create our own custom collector, which I think is a little bit more complex and is more involved. But if it's a simple scenario of some output which comes from a script, which can be in a format that the Pandas collector can recognize, and it recognizes a number of formats, I think this is one of the easiest ways to do it. Absolutely.
Yeah. I think, as you said, in terms of effort to do the setup and to get it working, it's for sure the easiest one. Yeah, I agree. Sorry, my cats are around here. So yeah.
Okay, I think the next question is something that we've been asked a lot, but I think now we have a huge number of users and customers who use Netdata for monitoring Windows servers. A quick overview of how to monitor Windows servers or Windows machines using Netdata.
Mm-hmm. For sure. So as you guys know, we don't have a Windows native agent like we do for Linux or even for FreeBSD. So the only option we have and that we gave to our users is to do this remotely. So for you to be able to do this on your Windows servers, you'll need to install the Windows exporter. So you'll get the Windows metrics exported on a Prometheus endpoint. And then with setting up your Netdata agent on a Linux server, you can remotely scrape those metrics from the Windows exporter and collect them through this Netdata agent running on a Linux host. You should do this, or you need to do this for each of the Windows machines you need to monitor. So you just configure the endpoint to the Windows machine that you want to get the metrics from. And recently, I mean, a bit recently, we enabled you to create what we call virtual nodes. So in the past, when you did this kind of setup, all the metrics will appear under your Linux agent in a section on the table of contents. But we understand having these nodes as separate entities in Netdata Cloud by themselves, it's important. So you can filter by them, you can do a lot of actions on the charts by them. So we created what we call virtual nodes. You can set up as many as you need for these Windows machines. And what it will do, it's all the setups that we are speaking about are done on the Linux server. So you need to do the configuration of the endpoints you need to scrape. You need to configure the virtual nodes you want to create for each of the Windows machines. And then when you connect when you access the Netdata agent dashboard or connect the agent to cloud, you will see each of these individual Windows machines as a node by themselves on the UI, and that you can use then for filtering, slicing and dicing the charts, and all those kind of things that you will do with a normal node, let's say.
And I think one information which I would like to add is we are introducing some automation of Windows uh, collectors. So you can actually run a script from your Linux machine and configure multiple Windows servers as long as the Prometheus exporter is installed. We will be coming up with some more information in the near future, but that's just FYI.
Yeah,
Um,
good add-on, because we are seeing a lot of recent users asking for this, and we know the pain it is to do all these setups manually. So for sure, it's an improvement that we are trying to do.
yeah, yeah, absolutely. Okay, moving to the next question is how do I centralize my logs? People have started using logs monitoring quite extensively, but log centralization is a common question that we get. So if you can
Mhm.
briefly explain that.
Yeah. So we recently did create an integration to systemd journal. So in our Netdata UI, you can visualize systemd journals on our dashboards. And typically, this is a journal on one server. This is using what we call also the functions. So if you see the top and the logs tab, it's basically a function running on an agent. So we have a function that is querying the systemd journal log on a server. To be able to centralize logs, we use some of the journal capabilities. So when you want to do log centralization, you can configure what is the system journal remote, so the centralization point, and then you can configure the system upload on the production system. So if you see here, in this case, we have our log sources that can be, we'll see in a bit what is this kind of files. So the API that is writing to the journal, systemd journal, and you can have some remote journals coming from another server. So if you have, again, a centralization point, you could be using that centralization observability point to collect the logs from all your child nodes that you have that you want to get the logs from them. So in this case, this journal that we are seeing here in the between is collecting the data for himself and collecting from as many remotes as you want. If you need to upload it to another journal log, to another centralization point, if you wanted to have a follow-up there, you could use this system journal upload to do that. So the Netdata agent runs this log centralization point, as we said, and aggregates them in an unified way. So you can have multiple child agents centralizing their logs to a centralization point that is going to be the observability centralization point that we spoke in the past. And then, of course, with Netdata UI, you can query those journal files for that server and for all the other servers that it collects and see them on the dashboards. Yeah.
Great. I think, so as you mentioned, all the logs are being visualized using the journal D logs. So the next question will be, how do I send custom logs or logs from my applications to be visualized on Netdata? If
Mhm.
you can take that
Yeah, yeah.
quickly.
So it's part of the part of the diagram that I skipped in the previous slide. So when we also made the choice to send our Netdata logs to systemd journal, we developed two tools, that is the log to journal and the system cat native. So you can use the log to journal to convert any structured log files in any of these formats, JSON, whatever format you have, into systemd journal log entries. So as I said, the log to journal is designed to do that transformation from preparing the data from the files to be able to export it into a systemd journal export format. And then system cat native, the other tool that we mentioned, is going to be able to put them on a namespace. So it's basically the combination of the two tools that will create a pipeline for transforming the files that you get from an Nginx or an Apache or other kind of application, and then transform them into a native, let's say, systemd journal format. And that way, you will get all of your application logs, or the ones that you want, in the systemd journal, and be able to see them, of course, then in the Netdata Cloud UI.
Thanks, Hugo. The next question, I think, will just be a brief listing of what all functions do we support, right? And especially given that we have renamed the tab where we visualize functions as top. So, what all top functions do we support?
Yep, yep. So again, this is to create awareness. What this top tab on our UI also allows you to do. When we started creating these functions, our goal was to replace typical SSH commands typical commands that you run on a terminal. So to avoid having you to SSH into a terminal to do a top command or any other kind of command that would allow you to keep your troubleshooting journey. So we brought this into our UI. So from the Netdata UI, you can trigger one of these commands, let's say, through the dashboard, and say, I want to get this from this node, and run that function there. So the main ones that we have are the block devices, so getting this IO activity, which replace the iOS stat. And each of these functions, by the way, it's important to mention, is linked to a plugin. So if you have this plugin disabled on your Netdata agent for some reason, you're not able to run that function or see that function available on the UI. So if for some reason you don't see one of these functions, make sure to check that the given plugin is running on your agent. So that's, I think, an important point to mention. We have a function around containers and VMs. So to get insights into the resource utilization of these containers and the virtual machines that are on your machine. So this replaces Docker stat, systemd, cgtop. So these kind of commands you'll run on terminal. We have EPMI sensors, so reading status of these EPMI sensors, again, replacing EPMI sensors command. Mount points, which kind of relates to the DF command. So usage of the mount points, available space, all these kind of stats that you usually get from this command. Network interfaces, network traffic, packet drop rates, interface states. So the commands by bmon, bwmng. So these are the data you get on the UI. And one recent function that we created, it's the network connections. So we have like a network viewer kind of that is reporting all the traffic and all the processes across IPv4, IPv6, TCP, and DP sockets, and classifies them as inbound, outbound, local, or listen. So it depends on the flow of the connection. So we try to bring a kind of a network viewer, let's say, for what's happening on your host, and you can see how the applications are distributed across these classifications that I just mentioned. So an important probably function for you to look at, and it's kind of recent. Then the processes. So this gets you real-time information of the system resources around processes that are running on your machine. So top and htop commands. System the list units. Again, information about the system units and their active state and description that are running on your machine. So replaces the systemctl list units, and then systemd services, which is resource utilization from all the systemd services that are running on your machine. So replaces systemd cgtop, for example. The last two that I'll mention are kind of a specific to Netdata. So we have a function about streaming. So if you have children or a parent, you can see what are the connections to and from this agent. So you can see what's the connection, if they are active, if they are sending data to a child, or a parent is receiving data. And you can see like information about number of metrics sent, the connection uptime that is there. So you can kind of stay on top of the streaming processes that are happening on your infra. And lastly, the Netdata API calls. It's like a real-time tracing of API calls made to the Netdata agent. So when Netdata Cloud or the agent dashboard is making a request to the agent, you can trace that, and you can see what calls are being made to your agent, and see in terms of the status, what was the query that was made, elapsed time, and more information. So it's kind of for you to understand what the kind of API calls are made to your agent at a point in time.
Okay, I think we've come to the last question that we had in this deck, Hugo. It's also a very important question. We've briefly touched upon this, but for users who are using the Netdata parent agent dashboard, which does aggregate, which does provide an aggregated dashboard across the child agents, why do our users need to use Netdata Cloud? What are the benefits that you get?
So I kind of recently we did or made the choice to provide the same cloud, the same UI, let's say, across cloud and the Netdata agent. So as we said, a Netdata parent agent can act as an overview, let's say, of part of your infrastructure, but there's some capabilities and features that are different. So if you consider in terms of scalability, a Netdata parent agent can only scale vertically. So it is limited to the resources of the net parent agent. So you can connect as many children to it. You can have as many metrics being kind of stored on the parent because of that. So depending on the sizing of your parent agent, you're kind of limited in a way in terms of scalability. If you look at Netdata Cloud, you have the vertical scalability, as we have, like we said, we connect parents to cloud, but then you also have horizontal, because you can have as many Netdata parent agents as you want connected to cloud, and this gives you still a unified dashboard. So independent of the number of parent agents that you get, cloud will always give you a single view across all parent agents. So it's vertical and horizontal scalability. In terms of high availability, we spoke about active cluster, so having two or more Netdata parents to act as active cluster between themselves. But as we said, the fallback, if one parent goes down, it's a manual fallback. You need to know, oh, my parent A went down, I need to connect to my parent B. So you need to go to the local agent dashboard of parent B. If you look to Netdata Cloud, you can have multiple active clusters. So you can have multiple of these parent clusters connected to cloud. And in terms of user, this is totally transparent to him. So cloud knows always where, or the best parent, let's say, to get the data from. So if one parent is down, it will automatically query the other parent. So this is kind of a transparent to the user. Considering in terms of observability range, the parent agent, as we said, can drive this multi-node infrastructure dashboard, but its scope is limited to the children that are reporting data to him or streaming the data to it. So that's kind of a limited to the DMZ, for example, limited to the cloud environment where the parent is running. So it's limited to that. If you consider Netdata Cloud, it's a multi-cloud and hybrid cloud environment. So you connect parents from different DMZs, different cloud deployments, all to Netdata Cloud, and you access from the dashboard all of them at the same time. So you're not restricted to this kind of, let's say, enforced limited zones that you have on your infrastructure. So in terms of capabilities, those are the main differences. If we look in terms of features, so the centralized configuration management, if you look to a parent, as we said, if you have the parent running the health for the children, you have the alert centralization configurations on the parent, but that's kind of it. If you look to Netdata Cloud, at the moment we have alerts collectors already available from cloud, And we will have access to other settings like the streaming, the retention configurations, all of that. So you can do this from cloud in a case like that. Um, the Netdata parent agent doesn't have role-based access controls. So in Netdata Cloud, on our paid plans, you have role-based access controls. You can have different roles for different people on your team, depending on the needs or their responsibilities. Um, on Netdata Cloud, you can have rooms to organize your infrastructure. So you can segregate your infrastructure per the type of servers, the environments that you have. So it's kind of up to you the way you want to segregate them. And then on a Netdata parent agent, it's all of the child agents on the same, let's say, local room. You don't have a way to split them in rooms. Cloud gives you access to the net notifications mobile app. I'm missing here. It's of course it's in the paid plan, so I need to put there in brackets. But the parent agent doesn't have the mobile app. Custom dashboards on the Netdata parent agent. You have access to create one custom dashboard that is stored on your browser local storage. In cloud, you have access to custom dashboards. And I think, as we mentioned in one of the previous slides, access from anywhere. So if you are restricted to accessing your agents on through a VPN, through because of firewall restrictions, they need to be on the same network, on the same zone. If you look at Netdata Cloud, it's that part is irrelevant. So as long as your agent can send the data that cloud asks to it, you can access it from anywhere. So you don't need to be restricted to VPN connections and those kind of things.
Okay, we've actually run out of time, and I'm really thankful to all the users who stayed till the end. But maybe if you're still around for a few minutes, if you have any questions that we can answer, we can take it here, or even otherwise, you can post them to us on Discord or on our community, and we will definitely get back to you. So, if you're still around, we are still here to answer your questions. Yeah, while we wait for some questions, thanks, Hugo. I know that was quite a laborious session. I don't think we expected it to run the entire hour, but it did because I think we had quite a few questions, all the important questions from our users. So, yeah, thanks for doing it. And I'm sure you'll need a couple of glasses of water at least.
And hopefully this was helpful even for people that can look at this later in time. So it will be a good reference for people to refer to.
Absolutely.
Yeah.
Okay, I don't see any more questions. I'm pretty sure it's because you were extremely clear. We get a thank you. Thank you very much, Axel, for staying till the end. And we will continue to have some sessions like these around the technical aspects. So, any questions that you may have, raise them to us, and we'll include them on our next FAQ and things like that.
Yeah.
Thank
And
you
if you
very
have
much.
suggestions of topics or anything that you like to see detailed and explored, this is the place to go about it. So feel free to share.
Okay, if nothing else, thank you guys. Thanks for staying with us. And thanks, Hugo,
And
for
thanks,
taking.
Satya, for joining me on this one. Bye bye.